Well, hi, good morning, and welcome to my shop here on the 4th of May. And what I'm doing here is I'm going to be finalizing the alignment on the radio. Now that I think I understand everything I need to know about it, I think I can get through it properly. The first thing I wanted to do was verify the IF frequency once again. Since I had some conflicting information there, it sure looks like it's tuned to 457. That's what it looks like, but I want to verify that. So you can see on my scope here a line. What I'm doing there is I have the sweep generator operating with 455 in the center of the sweep. That's what's going on here. This is about 425. This is about 490, something like that. This is roughly 455 in the middle. And I have another signal generator going, this one here. I'm going to beat this one in. The two signal generators are just basically connected together, feeding into the grid of the mixer tube here. In order to get this display, the scope is looking at what's happening on the input to the volume control, which is an okay spot usually to pick this kind of stuff up. So I'm going to switch to this camera, and you'll be looking right at the scope more closely. Now, it's not in the middle because it's very hard for me to calibrate the scope properly using the sweep, so I know for sure what frequency is what along here. Very roughly though, that's 455 in the middle, and this would look like 457, 458, something like that. But we can't rely on that. So what I'm going to do is I'm going to bring in a second signal and beat it against it, and it's going to cause some wiggling of this frequency here, this line here. And the funny wiggle should move across, and when we get to this point I should be able to read directly what the frequency is. So let's give this a go. I'm going to tune the other generator in. Oh, kind of see it right on the peak there. Now that's about the most I should get. And what is the number? Kenneth, what's the frequency? 458. So now I verified this two or three different ways now. No question the IF is off, and I can't bring it on to 455 because the slugs won't get me there. Or will they? Why don't I make one more attempt? One more attempt. I can't resist. One more attempt to move. I got all this equipment here. Now's the perfect time to do it. Let's give it a try. Okay. One piece of equipment that's missing though is this meter here. I need this guy going too. So this is measuring the AVC voltage. Basically, it's AVC voltage. Just letting my meter warm up. Here's what's coming out of the speaker. Yeah, with the sweep, this isn't so helpful. I think as I bring this other frequency across, even with the sweep going, we should see a rise on this. Let's try this. In fact, it's sitting on 458 right now. So I'm going to take it off. Okay, I see nothing going on with the meter. Now we can see it because I've increased the output of the what you could call the marker generator. Number this time 457. How is it a almost 58? Well, can't get it much more accurate than that. Okay, we're gonna take a shot at moving it. Let's try it using the scope here. So I'm gonna remove that. Okay, we're going to watch the scope, and I'm going to try to move that dip to the left. I've got 4 adjustments to get there. Get the right screwdriver here. Okay, each one is going to kind of, well, let's just start. Let's just see what we can do here. So I'm sticking the screwdriver in on, trying anyway. Okay, it's not cooperating here. Okay, I'm in. You can see it move a bit. That's the direction we want to go. But it's getting weaker because this is one of 4 things. So I'm turning this all the way until it's where it needs to be. Of course, we don't know where 455 is exactly. We're going to move it that way. Okay. Now I'm going to go to the top of the same transformer. Try to move it. So this is the sticky one. Now, we're going to stop right here because now I cannot move the one slug. So because of that, we're going back. A valiant effort to get this to 455, but it's not going to do it. Now we just want it to be as strong as possible. Okay, might as well fiddle with the other slugs too. So I go in the other transformer. It's hard to get my screwdriver to settle in. Come on. What's happening? Yeah. Try again. I think that's it there. Yeah, that's it. So I seem to be getting farther and farther out. And the last slug here. Got it in yet? Yeah, that's it. Okay. I think I've been fiddling with it. So again, it you know, that's the spot there. Wrong one. Okay, and now we're going to measure the frequency of that, and this will be the end of the road here. So where the greatest influence occurs, right in here. What's the magic number now? 459. It's gone even further. 459. Now is that adding up with the AVC? So we're going to see what the AVC meter says about where the peak is here. Doesn't quite agree. And we're back to 458. Okay, I have flogged this to death. 458 is the number. So one of the challenges with aligning this radio is the dial face, of course, is missing. And previously I wrote all the, I transferred the position of the pointer onto some notes on the back that can be referred against the bracket here. I have a camera around behind, so we'll just flip to it. Okay, so you can see I've written 6 megahertz, 21 megahertz, 600 kilohertz, and I put a dot exactly where the radio should be tuned. You can see in the tuning bracket for the pointer, there is a little notch right in the middle of it, and I'm using that as the mark. Right. So we are tuned to 6 megahertz. You can hear the signal out generator. Turn it up a little bit. We'll just see how accurate that is. Well, I'm not going to get that any more accurate. Okay, so now I'm tuning for maximum on the AVC meter. That's the spot right there. Okay, now everything being good, I shouldn't really have to make any more adjustments, but we are going to do that. The oscillator does not need to be adjusted. And that's what we're set up to do here. So basically we're verifying the oscillator is still good for the shortwave band. We'll go up to the other end, 9.6 end of things, and check it there. It got quiet, eh? To me, that suggests as you're tuning up, the alignment is drifting off like this. Something like that's happening. So we'll tune this now to 9.6. Okay, that's 9.6. And we'll look at the back camera. I have to relocate the camera and ensure there's no parallax happening here. Okay, you can see the 9.6 dot. Now that doesn't look quite lined up on the camera here. Okay, I'm going to fix the focus on the camera. Just bear with me for a moment. Still doesn't look quite right, eh? There we go. Okay, so that appears to be, well, it appears to be right on 9.6. No, it's on the 1500 dot. The 9.6 dot is down here. Yeah, quite a bit. Okay, so here we have one to adjust. Oh, but wait a minute. This is the wrong 9.6. This was when I interpreted the glass panel incorrectly. And that's probably more like 9.75. So 9.6. Just gonna have to kind of rough it here. Put 9.6 about there. Wow. I think it should be about there. The 1500 dot doesn't mean anything. It's just the distance from the 9.6. Let me look at the pointer while I do this. It's a short wave band. It's not that critical to get this absolutely precise. So you know what? I think I might accept that. Okay, so that would be the oscillators done. Now we go to the broadcast band. So I didn't make any adjustments there in the end. Go to the broadcast band. 600 kilohertz. Cores of the oscillator and the RF coils. Cores of the oscillator. the broadcast oscillator is through here. And okay, 600, right, 600. I have to go to the other end here. Looks like I can tune this radio without moving the pointer. See how this string is swinging back and forth? But it's not, it moved a little bit there. So I'm just affecting the tension in the string and able to move the tuning capacitor at the same time. But is anybody going to argue? That looks like 600 to me, for sure. RF coil. That certainly looks like it's fine on the oscillator. RF coil. RF coils. Oh, I gotta get this off. Ah. Forgot about this. Okay. Good. Broadcast oscillator. Broadcast RF. Oh, I can't do it with this. I need that long, skinny one, that's right. Making sure I go in the right. I think I have it there. Looking at the ABC, it's not making any difference. Hold the fort. Am I in the right spot? I'm in the right spot. Signal level too high. Very weak. There. Now we do broadcast 1500 RF trimmers on gang. Okay. 1500. See how all the mechanics are working under the string tension there. Okay, 1500. Let's go back to here. Very low signal. Okay, 1500. 1482. RF trimmers on gang. Do you not do an oscillator at 1500? And the answer is no. At no time do you make an adjustment for the sake of the broadcast band at the high end, oscillator wise. Yeah. Okay, RF trimmers on gang. This might be where this radio really went off the rails here. I'm gonna just move this over here. Gotta keep an eye on that meter there. RF trimmer. So oscillator and trimmer. And rather antenna and okay. Trimmers. Here we go. Down. Up a teeny tiny amount. That's one, now the other. Down. No peak appearing. Peak appearing. And that's the end of the broadcast band. Cores of the oscillator and the RF coils. Okay. Next band. Don't care much about the broadcast band really in this radio. Next band we go to the first shortwave band again. So we go back to 6 megahertz. Back to 6 megahertz. Back to 6. Megahertz and camera, and we dial back to 6 megahertz again. This time we are doing cores of oscillator. No. Cores of RF coils only. So in this case, we want to tune the radio in maximal. Turn the volume down here. That's a pretty low signal it's receiving. So I'm just making sure the radio is tuned dead on. Tricky with the ABC active there. Okay, there we go. Not quite lined up, is it? Is there some reason why I should affect the change here? Should I jump back? I left this one alone last time, didn't I? Core of the oscillator coil. Could touch this one up a bit. Okay, maybe this is where everything goes wrong. Shortwave. Because I'm... Okay, there's 6 megahertz at the 6 megahertz spot. Yep. And now we do the cores of the RF coils. Okay, shortwave RF coil at the front here. Shortwave. Okay. And watching this meter here. Down, down. Good. It's good. And then we go to the other end. Oh, RF cores of RF coil. So we got to do on the back here too. There's my mirror. So we are doing the shortwave band, and that's this one right here. Meter down, meter up, meter down. There we are. Ever so slight improvement. Now we're on to the 21 meter band, the 13 meter band, 21 megahertz. That's the last band. And we want to do this at 21 megahertz. 21 megahertz. Okay, 21 megahertz. Hey, I've got that. Okay, I want to take a look at the position of the pointer. 21 is just a hair below there. We should hear it. It's off a little bit. There's 21. And core of the oscillator and RF coils, the whole shebang. So we start with the oscillator on the 13 meter band. At this point in the alignment process, if you make a little mistake, the chances are you've adjusted a core you've already finished with. Like I'm trying to finalize this. I don't want to make any mistakes. If you go in the wrong core, you wreck the whole thing. Whoops. I'm still looking at that. Okay. Now, why am I not hearing it? Because we're going to bring it in with this. So we're at 21. 21 on the back. Can't be pushing on this tool. Okay. Okay, once again, that's as close as we're going to get. Maximize it. This is interfering. Okay. Now we do the RF. Again, we're on a 13 meter band, 13 meter band. Okay, we're in. It's right there. And then on the back, 13 is that one. jumpy here. Okay, that's that. That's the 13 meter band. Now the next band in the list. Oh, another thing at the 13 meter band. Oh, cores of, okay, so at 21 megahertz you do cores of oscillator and RF coils. Then you go to 22 megahertz and you do the oscillator and RF trimmers on the gang. What are they saying here? Oscillator on the gang. And we know it's a band spread. Every one of them says oscillator. Cores. This is the only one that says oscillator on the gang. This is the only one. Okay, so we go to, okay, something special going on here. So we go to 22 megahertz. Okay, 22. We dial up 22. Where's 22? Not that far away, is it? Oh, way the heck down there. That is 22. Pardon my poor writing, so we'll go down there. Well, we should be hearing it. Whoa! Now that's a little loud. Yeah, you know, this is the point where I didn't understand how that capacitor was working. And so I went wrong at this point. I think I've just basically started losing my mind. So we're 22. Oscillator, hold on. Oscillator 22. Oscillator and RF trimmers on gang. So everything's up on the gang now. But it's all the small plates. Wouldn't it be? Those small guys. Okay, so first of all, oscillator. Oscillator, pretty sure it's this. Wow. What are you doing? Oh, it's wrong plates. I gotta hit the stators. So we're not hearing anything, so it's hard to recognize the oscillator, but I did check it earlier, and I trust what I did. So the first set of plates is the oscillator plates. I should adjust the trimmer, bring in the tone at 22, and 22 on the back. Okay, let's do it. Okay, and then the trimmer, we'll just go hunting. Oh, I passed it. There it is. Something funny going on with it. Need a little more adjustment here. That's a little too far out. The screw is very sensitive to mechanical pressures and all that kind of stuff, so it's jumpy too. How's that? Just get it a little wee bit better. So I'm still looking at the camera view of the numbers I wrote on the back of the plate, so I'm able to see that while I'm doing this. You can't see it. Still, oh, just a wee bit. It just wants to oscillate between two positions. The screwdriver's too small. I just can't get control over it here. A much bigger one on there. I don't know if this will fit. Much more metal. It won't fit anyway. Let's try this one. This one might be just. I think I got it that time. Bingo. Okay, tuned for maximum meter. There we are. And now we do the RF trimmers, right? Oscillator RF trimmers on gang. These again are the small plate trimmers. I'll keep trying with this. Okay. Trimmer of the small plate. Goes right on. And antenna trimmer of the small plates. It's right on. Somehow I managed to get it on before. Okay, and now we go 25 meter band, 11 megacycles. So 25 meter band is first band after shortwave band. Broadcast shortwave, 25 meter band. We tune to 11.8 megacycles. 11.8. Where's that? Right there. Okay. 11.8. Now we'll change the signal generator and see what happens when you get to 11.8. Hi. Okay. So I want that really to be 11.80. So now we're going to adjust an oscillator core. It's a core for 25 at 11. At 11. Core for 25. It seems like I'm overdoing the double checking here. I just touched it. I just touched the core. So, you know, for sure this is the you saw it right there. Rubber mallet, these things wander. I used to think they waxed these to keep kids from playing with them, but now I think maybe they waxed them to freeze them so they wouldn't drift. So this is the oscillator, and we want it to be 20. We want it to be 11.8. I think I'm going to have to set this just to 11.8 and go hunting for it. There it is. Okay, maximizing on the meter. Okay, I got it. Oh, what happened there? So we're going to make a mistake now. 25. Don't make a mistake. Oh boy, it's just, well, that's a problem with this radio, isn't it? Wow. Okay, I think I'm probably killing myself over something that's not stable. That's probably what's happening here. 11.8. Now we do the RF coils for 25. First I got to tune the radio. Absolutely dead on. Make a big mistake here if the radio's not. Okay. 25. There it is. 25 on the back. Would appear to be what did I write back there? That's shortwave. This has to be 25 right here. I imagine all the banging a radio like this would receive between the time it was aligned in the factory and the time it made it into somebody's house. There we go. Okay, let's just stay in there. What are the chances? Almost sounds like it retuned a bit. That's good. That's good. Okay, so that was not so bad. Next one, 19 meter band, 15.3. 19 meter bands, and the next one over. 19 meter band. You want to do this at 15.3. 15.3. Okay. 15.3 is right here. 15.3. Coming in low. 15.3 cores of the oscillator. 19 meter band here. Another very sensitive one here. Okay, so this should really be 15.3. So head in that direction. Oops, don't go too far. Try to find it. There it is. Okay, now we're going to go to 15.3. give it a max up there. It is max. It should be max there. Lots of backlash. Fine movements got a lot of backlash in there. So now we want to peak that up with the RF coils. 19 meter band. Okay, this is one of the RF coils. Up, just off a little wee bit. Okay, and then the antenna, 19 meter band. Well, I got 16 and 19. I'm looking at it in a mirror, upside down. It shouldn't be too hard. Make a mistake. So 19 is here. 19 is there. Just gotta get the screwdriver to seat. There. Okay, it's in. About right. Okay. And what are we left with? One more. 16 meter band. 17.8 megacycles. There. Well, let's see what happens. 17. Pretty close. 17.8. Is that right? Yep, 17.8. Just gonna give it a little more power here. Now we want to use the oscillator adjustment to bring this in on the 16 meter band. 16 is up here. Okay, we're in. Find that sound. I'm going to turn this down. Fantastic. Now we do the RF coils. 16. Right in. It kind of feels like it's at the end of its run, but it has a peak right there. And then 16. Okay, that's the end of that slot. 16 antenna RF. That is it. And I have a pretty good feeling about it. I think I did it all correctly this time. Fantastic. So I'm going to stop for a while. I'm going to throw this guy back in his cabinet. I'm going to mess around and see how accurate this really came out and what kind of stuff it can pick up at this point. Ooh-wee. you know, right to the end. This radio's throwing a challenge. So I'd like to put it back in the cabinet. I think they've made it impossible to do that. I was very smart and clever. I put the rails back in properly. There they are. And all I gotta do is slide the chassis in. Except these are interfering completely. I cannot get over this and then down the other side and in because the control knobs are banging into the cabinet front here. It would look like you'd have to take out the whole speaker board to get space to put the radio in. That's dumb. This is a quick release thing. Yeah, baloney on that. So I get all the way there. I cannot get over top of the screw. No matter what you do. Well, that's why these rails were loose and half out when I got this radio. So what are you supposed to do? Like drop this? But then it's covered by the chassis. Once you put the chassis in, you can't tighten this up again. Can't get a wrench on the nut. What kind of a dumb arrangement is this? You know, there are two short screws that came with this. They're here somewhere, but they're supposed to go into here. I wonder if the two short screws aren't supposed to be up here, and then these long screws can fit through here too. I wonder. Here's a short screw here. That's a really short screw. Well, I'll start by taking one of these out and seeing if it goes in here. Oh my gosh. You know, you'd think in the world of radio repair that putting the radio in and out of the cabinet is you know, kind of the easiest part of the whole thing, but no, it's not. It's sometimes yes, sometimes no. This is definitely a long shot here, but maybe it's a way to solve this. It has these curved washers, which I believe are supposed to pull into the center of this hole they have here. To kind of center it up. I think that's what's going on there. Okay, will this go in the end? I don't think so. Ooh, close but no cigar. Well, I gotta stop and think. I'm gonna find a properly threaded screw that's shorter than this, or I'll have to cut these down, or what am I not thinking of? I mean, I could put them through, you know, this way, and the head would be lower. I could also washer this up a lot, like I put a pile of washers in here and have the screw not go down as far. Maybe that's a solution, or maybe I put the washer in the other way around. These warped washers. I don't think that's going to give enough clearance though. Okay, I got the challenge here. So what I'm going to try here is just put a spacer in here. It's just a oversized nut, and see what that looks like. I've turned the washer around too. Well, that barely comes through. Enough, certainly comes through enough. That's good. So this will solve the problem, unless the width of the nut is a problem, which I don't think it will be. Unfortunately, I've got these feet here, so this is even though it's protruding, it's still way high. Okay, got to treat the other one that way, and we'll stick that thing back in the cabinet. Okay, I reached that point where I think I'm doing the final test. So that's the outdoor antenna connected to the shortwave side of things. Just bang this around a bit here. Okay, I think we're ready to go. Still no AM antenna connected, so I'm not gonna sweat over that. I'm going to find out first what the radio receives. Even though again it's not the best time of day, it's not quite 12 noon here. But we'll see what it does, and then I'm going to use the signal generator, and we're just going to check a number across here, just see how accurate the radio is. Here we go. Switch on. So I think we're on the, what are we on? So we are on the broadcast band, no antenna. No antenna at all. There's nothing back there. Wow. There is nothing back there. Let me just grab a wire. Okay, so I'm the antenna. Not particularly directional. Well, that's pretty good for me being the antenna. Okay, we're off to a really good start. But I really want to know about the shortwave bands. So first band will be 6 megahertz to 10 megahertz. We might get some stuff up here at this time of day. And over. Band indicators are a little out of alignment, unfortunately. So we shouldn't expect anything down here. Maybe this is around 7.5 here, maybe right in here. No. Maybe up around 9. Pick up aircraft in this area. There's a number of places you can pick up aircraft, and I'm not talking about little Piper Cubs. I'm talking about big jet airliners flying over the Atlantic Ocean. They rely on shortwave radio for communications. Yeah, with all of its problems. Fading, all that stuff. Okay, we're getting into the 9 range now.
Generations of believers have worshipped bias. Go ahead, if you would, with the message verses. And I heard another voice from heaven say, "Go out of her, my people, that ye be not partakers of sins."
Okay, that's 9.33, I believe. So let's see where it is.
Single believer today should follow the Lamb whithersoever he goeth, and where the Lamb is leading to, straight out of Babylon. If this is the first time you've heard about the lunar Sabbath, we realise this is a lot to lay on you. We don't expect you to take our word for it. What we do ask is, please, give me this afternoon's help. We've talked about the biblical Sabbath.
I think that's 9.3.
And if you've missed it, you can listen to it on our website.
It's close.
On our website and on YouTube as well, where you can learn.
Okay, so we'll do the frequency check on this band. I'll dial up exactly 7. About the middle. I think that's exactly 7. Oh, whoa, wait a minute. There. Okay, so I dialed up 7 here. Not 7 there, 7 here. Let's see what happens. I don't have this guy connected to anything yet. So what we'll do is we're going to try to broadcast with this. Assuming the... Just stick it up here for what it's worth. What did I say? I was going to 7 right on the money. 7 on the money. 7. Quite 7. So what I'll do is I'm going to set this to 7. That's a fairly weak signal though. It's picking up. Set this to 7. find it on here. Let me boot it up a little bit. Find it on here. So try as I may, I still missed. By how much? So here's where 7 showed up. Oh, I didn't miss. That's the parallax. I was looking at it on a funny angle. That's dead on. Wonderful. Okay, next band. Okay, score 1 for me. Next band. So now, wow. Can't calm it down. Maybe it's tuned into something a little bit. Now we want to go to see what's on here, because we have the antenna hooked up. So that's Cuba. Cuba comes in 2 places.
Rap star, estrella de rap, de Torres Tremonti Bartlett, conocido artísticamente como Polo G, debuta en el primer lugar de la lista.
Okay, let's pick a frequency. 11.8. I can't turn this down. 11.8. Wow. Okay, that's pretty good. I had to put a lot of signal out because I'm just using this. And even though I have this loop sitting near the radio, it's not sitting near the antenna. The antenna is out in my backyard. So my backyard is actually that way. The antenna is about 15 feet, 20 feet away from here, through the wall, up, up, up. Okay, well, I'm pretty excited about that. 11.8. So if we put this right on 11.8, and we tune it in. Now we'll take a look with the other camera. How close are we to 11.8? Drum roll. Drum roll. Oh my gosh, we're smack on. Now you gotta remember, these bands were aligned in the middle here, so shouldn't be too surprised they're bang on in the middle. Might not be so good down here. Why don't we try it? 12.2. 12.2. Okay, and then we'll go 12.2 here. Yeah. 12.2. Wow, it's way out. .1 or 12.1. It should be way up here. Well, let the truth be known. Next band we're on now is the 19 meter band. So if we, let's go up to the 15 here. Let's try it at the top. Again, this is bound to be accurate in the middle because that's where I aligned it. But it may not be accurate on the edges. 15. Let's go. Put this right on 15. And we'll find it. Okay. Doesn't look too accurate, but let's see what we got. It's pretty close. Okay, if we go in the middle, take a 15.3. I think that's exactly where I lined it. We'll pick 15.3. That's the pointer back there. Okay, and we'll find out what happens. Sorry for the focus, I'm just not bothering with it. Okay, so we put this on 15.3 and then we look for it. 15.3 in the red, don't get it wrong. Oh, it's right on. Well, yeah, I'm in the middle again. So let's just check it out.
Cable TV in England
Oh.
on One-Chain Digital CATV, in China on Nantian Cable TV,
Oh.
in Taiyuan on North Taiyuan Cable TV.
I think that's
Taipei,
15,770.
Qingpingtao, Chuanlian, Da'an, Wenshan, Xintaipei, Xintangcheng, and Yangmingshan Cable TV.
Radio China.
And in Ilan, Channel 4 on Union Cable TV. In Tanzania, in Arusha, Dar es Salaam, Dodoma, Morogoro, Norfolk, Mwanza, Tonga, and Zanzibar on Channel 921 on CTV. In Trinidad and Tobago on Airlink Communications. Throughout Uganda, YOTV. In the United Kingdom on Connected Freeview and EETV via Vision TV, Freeset, and Sky on Showcase TV. In the United States on Junico-based TV, Final TV, as well as on Public Access TV. In California on Mid-Penn Media Center, BCN TV, KMVT, KOCT, CMAT TV, Access Sacramento, Comcast.
I'm just listening to this in case you're wondering what I'm doing.
And Pasadena Media. In New York on Brick TV, MNN, PATV, Long Island, QPTV, and White Plains PATV. In Washington, D.C.
Let's see what actual frequency we're on. I'll beat it with the 770. So this is actually 15,770, and I'm way out. Well, way out. Maybe that's a little strong. 770 would be just a little above that, actually. The question you might ask is this good enough to find stations? That would be one way to judge the quality of the accuracy. Can you find the station you're after? And I think the answer would be yes. Well, we don't hear WWV. And that's actually, oops, just above. Let's go to 15. Let's see if WWV is there. Signal generator out of the way. No. Oh. I think this is it here. I think I heard his voice for a moment. Okay, next band. (16). Now, there's a chance there's some stations up here. 16-meter band. Might be one station. Then again, maybe not. Okay, so if we go to the top, let's say 17.4. Okay. 15.4. Okay, fairly close. We go back. That's good enough. Tune the radio and find out where it is now. That's not too far away. Okay, I'll do the last band. Can't imagine we're going to pick up anything here. All's quiet. 22. We'll pick 22 as the test. Okay, 22. Remember this 21084, add 900, what do you get? 22. When I vary this, the signal strength's going up and down by a factor of 10. Hear the difference in the radio. Let me tune the radio right on first here. Okay. Now, could you hear the noise go down on that last one? Noise way down. Not really particularly believable. Especially, it's not even hooked up to the radio, right? I'm still on this loop deal. Don't understand why it would be like that, but it is. Doesn't quite make sense. I mean, you think the signal would drop out as you got lower and lower, but it didn't. There we are. This guy's ready to go. I can't make him work any better than it is, except to stick the broadcast antenna onto the back of it. So yeah, this is what I was using. Okay, so it wasn't really clear. Just to shoot a signal out into space from my signal generator, pick it up on the antenna, deliver it to the radio. So I don't think I can get this guy any better. But his brother is still here, and I plan to go over his brother just about the same. Alright, don't think it's going to be quite as confusing. So thanks a lot for watching this whole series. We'll have a listening session with this guy and the other guy when they're done, to in the evening and all that kind of stuff. These are wonderful radios to tune and to operate. So great, thanks so much for watching, and we'll be on the other radio, the HC39 or 39HC tomorrow. See ya.